Good morning to all my YouTube viewers. In this video, I like to discuss about interference of light and its related problems. These problems are selective for competitive exam purposes. As students need to boost their level up to competitive position, so they require a brief form of selected problems so that they can make themselves more efficient towards getting the target. Now the subject matter is like this. One thing I like to tell you that problems you have to see carefully. When I am going to read the problems, you have to concentrate on that. You have to understand what is talking about that problems. Then solution will be in your hand. Now in first problem, in a Young's double slit experiment, how many maximas can be obtained on a screen including the central max on both the sides of the central fringes. Lambda is provided 2000 angstrom and small d distance between the slits 7000 angstrom. We know d sin theta equal to n lambda. Now maximum possible number of bright fringe only possible, that is sin theta equal to 1. Under that situation, n will be small d by lambda, 7000 over 2000, so it gives 7 by 2, which is 3.5. Now the result, as it is found that n equal to 3, maximum beyond central max, so on both the sides maximum 7 number of fringes will be visible, bright fringes. Now come to question number 2. Two coherent sources A and B are at a distance thrice lambda from each other. The distance from A on the x axis at which the interference is constructive there are 4 choices. Actually, we have to find out at what distance x that constructive interferences are available. From here we can see the distance between BP will be root under 9 lambda square plus x square. Now there is a path difference between BP and FE, and that will give us root under 9 lambda square plus x square minus x, which is the path difference, will match with n lambda, because n1 means first maxima, n2 will be second maxima, and so on. Now solving for 1, we can see that x is coming 4 lambda and it is not in the choice, so we have to look for next level, that is n equal to 2. Putting 2, we can get x equal to 5 lambda by 4. There is a choice on C, so this will be the answer. Next question, question number 3. In Young's double slit experiment, using red and blue lights of wavelength 600 nanometer and 480 nanometer respectively, the value of n for which the nth red fringe coincides with n plus 1th blue fringe. There are 4 choices. According to question, the position of the fringe on the screen is same, only fringe numbers are different for different colors. So y suffix n equal to n cap d by small d lambda for red will be equal to n plus 1 big D by small d lambda for blue. Now arranging them, n by n plus 1 equal to lambda for blue by lambda for red, and it will give us 4 by 5. Solving this, n equal to 4. So red, fourth red will coincide with fifth blue. Next, question 4. When light travels from rare medium to dense medium, what happens to the energy, frequency and velocity? Answer: velocity decreases, but energy of the wave and frequency remains same. Energy depends on the frequency and amplitude, that is 2 pi square small m capital S square n square. As amplitude and frequency remain same, so energy will remain. Now come to question number 5. In YDSC, fast maxima is observed at a fixed point P on the screen. Now the screen continuously moved away from the plane of the slits. The ratio of intensities at point P to the intensity at point O, that is central max on the screen. Now there are 4 choices: keep on decreasing, first decreases then increases, then remains constant, next first increases and then decreases. As we know that d sin theta equal to n lambda, n equal to 1 for first max. So here we can write d tan theta when theta is small equal to lambda, then small d y by capital D equal to lambda. Now here it is understood that capital D increases, but small d and lambda constant as the screen moves away from the slits. Then proportionally y will also increase. It means first bright fringe position will shift above position P, and in between first bright and central max a dark fringe will be there, and that dark fringe will approach towards P. So ratio of intensities at Phi to at O first decreases, and when screen will move further, then first dark fringe will move up further beyond Phi. So again intensity will increase. So choice will be first decreases and then increases. Intensity first decreases and then intensity increases. That means it is B. Next question, question number 6. The intensity of each of the 2 slits in YDSC is I naught. Calculate the max and minimum separation between the 2 points. Calculate the minimum separation between the 2 points on the screen where intensities are 2 I naught and I naught. Given the fringe width equals to alpha, fringe width is provided, that is alpha. Now there are 4 choices. As you know, I equal to 4 I naught cos square 5 by 2. Symbols have their usual meaning. Now instead of I, you can put 2 I naught, that is equal to 4 I naught cos square 5 by 2, phi 1 by 2. Now from here cos square 4 I naught cos square phi 1 by 2. From here we can find out phi 1 equal to pi by 2. Similarly, for the other one I naught equal to 4 I naught cos square phi 2 by 2 from here we can calculate phi 2, that is 120 degree, that is 2 pi by 3. Now phase difference is known, that 2 pi by lambda into path difference. Here path difference will be d sin theta, then 2 pi by lambda into d sin theta is the phase difference. Now phi 1 is pi by 2. Now from here y1 is coming pi by 2 alpha 1 by 2 pi, which is alpha by 4, and similarly y2 will be alpha by 3, then difference will be delta y equal to alpha by 12. Now the answer will be A, choice A. Next question, question number 7. In YDSA, the intensity of light at a point on the screen where path difference is lambda is I. Path difference is lambda, is intensity is I. If intensity of another point is I by 4, then the possible path differences at this point are. Now in solution, path difference is lambda, so it will be the first maxima, intensity will I max will be I. Now for the second, as it is given that intensity is I by 4, which will be I max cos square phi by 2, and phi by 2 will come cos inverse plus minus half, that means it will be pi by 3 or 4 pi by 3, that means phi will be pi 2 pi by 3 or 4 pi by 3, 2 pi by 3 or 4 pi by 3. Now phase difference equal to 2 pi by lambda into path difference. Using this formula we can see path difference is lambda by 3 and 2 lambda by 3. So choice A is correct answer. Now come to next question, question number 8. White light incident normally on a glass plate which is placed in air of thickness 500 nanometer, mu for glass equal to 1.5. The wavelength in the visible range 400 nanometer to 700 nanometer, that is strongly reflected by the plate is. There are 4 choices. Let us for solution. Number 1, phase difference for reflected light from dense medium will be phi equal to pi 180 degree, and phase difference for reflected light for rare medium, that will be 0. Therefore, path difference between the two rays 1 and 2 is here it is twice t, but the phase difference between these two rays is 180 degree. So interference fringes will form. Now as they are in opposite phase, so first maxima will take place 2n minus 1 into lambda glass divided by 2 equal to 2t. This is bright fringe. When we will take substituting lambda here, we can get as lambda g equal to lambda by mu g. Substituting this, we can get 2n minus 1 into lambda by 2 equal to 2 mu glass into t. Now here n equal to 1 means we will get first bright, that will be 3000 nanometer. If we go for n equal to 2, that will be the second bright, it will be 1000 nanometer. If it is n equal to 3, then it will be 600 nanometer. In the choice, it is found that 600 nanometer is available. So choice number D will be the correct answer. Thank you very much for good listening. I hope that these problems will help you and in the coming video we'll talk about diffraction phenomena of light. Now it is my request to share this video to in wide scale range. You can share this video so that many people can benefit of it, and if you feel it is acceptable, then you can like it, you can subscribe, and you can help others by sharing it. So have a good day, and thank you again for good listening.